So now we're going to talk about virtual memory. And virtual memory is one of the coolest parts of computer's architecture because it really combines the idea of trying to make the software work well with what we can do in hardware. So in talking about virtual memory, we're going to start off with three problems. And the first of these problems is what happens if you don't have enough RAM in your computer. And this problem was really the motivation for virtual memory in the first place. It used to be that RAM was really expensive, and so you wanted to use it very efficiently, and you needed to be able to run programs even if you didn't have enough memory. Now these days we tend to have tons of RAM in our computers, so this is much less of a problem. In fact, if you run out of memory on a computer today and have to use virtual memory as a result, it generally slows things down so much that it's almost not worth doing. But there's some other problems that we have as well. So we have holes in our address space. If you run multiple programs together and then you quit some of them, you leave these chunks of memory that are unavailable. We also have problems with programs writing over each other. So remember in MIPS, we promised each program that it could access 32 bits of address space, and so if you have two programs that both write to address 1000, what happens? Do they write over each other? How do we keep them from crashing each other? So after going through those problems, we're going to talk about what virtual memory is. And basically, it's just indirection. So virtual memory is the idea that we take the address that the program uses and we map it to the real address in memory. And by having this mapping going back and forth, we can do a lot of interesting things about controlling where the memory goes and how we use it. We're going to show how this indirection solves the problems above, and we're going to talk about the idea of page tables and translation, which is how we store the mappings and how we actually do the mappings. Then we're going to talk about how we implement virtual memory. So where do we store these page tables, these mappings between our addresses, and how do we make them run really fast? So we're going to make them run fast by adding hardware to the computer to make it faster. And then finally, we're going to talk about how virtual memory interacts with caches, because caches are an important part of making memory faster, and we want to make sure that virtual memory doesn't mess that up.